In this video, we will go over how to train a feed-forward neural network. We've seen how to classify with a feed-forward neural network, but how do we get trained weights and biases? To update the weights and bias, we want to train the neural network. To train a feed-forward neural network, there are a few requirements we have to meet. First, we need a feature representation of the input, for which we will be using our feature vector x. Next, we need a classification function to predict the class. We will be using many neurons to accomplish this task. The neurons come together to form the layers of a neural network. Next, we will need an objective function to optimize for learning. We will use the loss function, namely cross-entropy loss. And finally, we need an algorithm for optimizing our objective function. Feed-forward neural networks use backpropagation to optimize the objective function. What is backpropagation? We saw in logistic regression how gradient descent is used to reduce our loss. We can't do the same thing here because the layers depend on each other for their outputs. Let's walk through what training looks like conceptually. We take our input vector and the current values for the weights and bias, run it through each hidden layer, take the output of the hidden layer and the corresponding weight matrix, which we send to our output layer, which gives us a prediction. We use this prediction and the true label of this training sample to determine the error of the output layer. We then use the error of the output layer to calculate the error of the previous layer and so on. Using the error we calculated for all layers, we can use the error value to perform gradient descent on the layer to update the weights and bias for each layer. We then rinse and repeat for more training samples. These videos were inspired by Josh Starmer at StatQuest. Be sure to check them out.